Adventures in object-oriented programming. This is a beginner level session, but if you're an expert or intermediate, it might be like a really good refresher. This is my third time doing this presentation, so please go easy on me. I talk really, really fast, so if you like flail at me, I'll slow down a little bit. I've been known to do this in 8 minutes, so I'm going to try to do this in at least double the time this time. So we'll get started. My name is Fatima. I work for Digital Echidna. We're a 60-something development shop in London, Canada, so we do digital services and websites and creative stuff. I'm also on the leadership team for Drupal Diversity and Inclusion, which is a working group made up of volunteers in the Drupal community that's trying to create more conversations around making more inclusive spaces and being more accepting and advocating for the diversity that we have. So if you stop by the Digital Echidna booth, we have Drupal diversity stickers there too. All right, time for adventure. So I'm going to tell you a little bit about how this presentation works because it's a little bit quirky. We're going to have a scenario where we're going to be Pokemon trainers. We're going to take that scenario into sort of modeling a data, and then we're going to take that over to an OOP concept, which will be really basic, and then we'll pull that into code. So it's like a 4-step, sometimes 3-step procedure. Don't lose me, don't panic, and we'll start by going over what OOP is. And the way I like to think of it is that it's a way of organizing our code into objects so you don't have to repeat yourself. It's called object-oriented programming for that reason. It's really modular, so for example, if I want to create 3 different Pokemon trainers, I don't have to create the code for each trainer to do battle over and over. I can just create one trainer and then extend it and let it grow into different types of trainers and give them different types of features and things, and that's why it's really flexible. So let's start our adventure, and everybody knows when you start out in Pokemon, the first thing you do is go to Professor Oak and you select your starter Pokemon. Professor Oak also gives us a Pokédex, which is if you don't know, a Pokemon encyclopedia. So we're going to choose our starter Pokemon as Pikachu, and we'll take a little bit of a look, I hope it's not too light, at what Pikachu is like. Our Pokédex is telling us that the name of our Pokemon is Pikachu, the type is electric, and the type of attack that this Pokemon uses is Thunderbolt. So with some information about our Pikachu, we can sort of abstract out what these things are. I would kind of think of them as data points. So we have a name, we have a type, and we have the name of an attack. So this kind of gives us properties about our Pokemon. This data is starting to look like an OOP concept called a class, and we'll go into what a class is. I think of classes as blueprints, so they kind of build the shape or attributes and relationships of the container that you're trying to build, which in our case is a Pokemon. Classes are made up of two sort of main things. One is a property, which is a data point. For example, for our Pokemon, a property would be the name, which is Pikachu. You can also think of properties as variables. The other thing is methods, which are class-specific functions if you're already programming, or you could also think of them as tasks that a class can do. So let's create our Pokemon class together. Oh, is that tiny? Can you see back there? Okay, cool. To create a class in PHP, you use the special class keyword, and you have these little brackets. So we have class, the name of our class is Pokemon, and then we have 2 properties of the class, which is the name and the type. Protected is sort of a keyword in PHP that allows us to define the visibility of the property. There's also public and private. Protected means that we can only access it within the class itself. And if you can remember, Pikachu also has an attack, so we'll add the attack as a function if we want to do battle. For now, it's just very pseudo-codey. We have public function, the name of the function is attack, do something, and we return our very awesome attack. So now that we have a class for our Pokemon, how do we actually create the Pikachu that we have obtained from Professor Oak? In order to create the Pikachu, we have to create an object from this class, and I'll tell you what an object is. An object is something that's created from the class. What you do is you instantiate a class, which is just a fancy way of saying we create something from the class. And objects are all separate entities, so you can have a Pikachu, which is a Pokemon object, and you can have a Torchic, which is also a Pokemon object. There's a special method in PHP that helps us create objects a lot easier, and it's called a constructor. So let's take a look at what a constructor would look like in our Pokemon class. And it's basically a function with 2 underscores because the font sucks, you can't really see them. And it's called construct, and we're giving it the property name and the property type. And this is a sort of variable thing in PHP that allows you to know, like, I am within the class, so this class is name and this class is type. And what the constructor allows us to do is when we actually want to create a Pokemon object, we can just pass the new keyword, which says I'm creating an object, this is the name of the class, this is the name property, and this is the type, Pokemon type property. And then we have a Pikachu. And once we have a Pikachu, we can also call the methods inside our class, which would be like Pikachu attack, which is the only method or function we have right now. I'm going to pause because I'm talking too fast. And you can also create other Pokemon objects because objects are separate entities. So for example, if you have a Torchic now and it's a fire type, this is how you would create the Torchic object. And the Torchic object would also be able to attack. Give it a second. Okay. We're going to go on our journey, and this time we're going through the woods and a wild Pokemon appears, and we find a wild Eevee, so obviously we need to battle and capture this Eevee, which is really exciting. We get ourselves an Eevee, and our Pokedex tells us a little bit more about what this Eevee is. We know that the Eevee has the name Eevee. I need to work on that. And the type is normal. It's a normal type Pokemon, and the name of its attack is Tackle. So that gives us some more data about a Pokemon that's very different from our Pikachu, but they're both still Pokemon, so they share those similarities from the class that we created. So if we compare the two, we can see that they have a type difference, and they also have a different attack name. And so we want to think about how can we modify that very base Pokemon class that we created so we can account for these different types of Pokemon and these different types of attacks that they have, and how we can account for changes in the future that might come up as we gather more Pokemon types. And there's a functionality, or there's a concept in OOP that allows us to do this, and it's called inheritance. Inheritance is about sharing. It basically means that classes can share code. You can think of it like a tree. So there's a parent class, which is sort of the base class that has the functionality that all of the classes will share. And then there's child classes that take that functionality and then implement things of their own that the parent doesn't necessarily have. In our case, our parent class is that generic Pokemon class that has the name and type. And our specific classes would be electric Pokemon or normal Pokemon or water Pokemon, because they're all Pokemon, but they do have specificities like their type, and maybe in the future other things that distinguish them from the generic Pokemon type. So child classes can inherit the properties and methods of their parent class, and we can create multiple child classes that inherit the parent class. Let's look at some Pokemon inheritance. I like saying that, I don't know why. So here's our class Pokemon again, and I sort of took out the properties so we can only focus on the attack function for now. And if we create a class electric Pokemon, we have to use the keyword extends to show that this class is inheriting from the parent class Pokemon. And then we have the same public function attack, but we're overriding this function in our child class to give it a different type of attack, in which in this case is an electric attack. And if you have multiple properties or multiple methods, you can also override those, but I just gave one example. We can also take this one step forward and create a... Did I press the slide right? Yes, sorry. You can also take this one step forward, and you can look at the electric Pokemon class that extends the base class Pokemon and gives an electric attack instead of the awesome attack that we had in our Pokemon class. Or you can also create a Pikachu class that extends the electric Pokemon class and give it even more specificity, where Pikachu has a very specific attack called Thunderbolt. So this is inheritance in OP. So in this example, you can kind of see how all of our Pokemon can have the ability to attack, but you can go more deeper as you extend these classes, and you can get more specific as you go down that child's tree. Gonna wait a second because I'm at 8 minutes and halfway through. Am I going too fast? Are we okay? So we're okay? Okay, got one thumbs up. Thank you. So we've got our types sorted out. We're gonna check back into our journey, and we've been traveling for quite a bit and collecting a lot of Pokemon. And people have been telling us hey, you gotta do gym battles. You gotta win some badges because you can't go to the leagues till you have some badges. But we haven't really battled people yet. So one of our friends, Brendan, challenges us to a Poke battle. And so we're really excited, and we're like, all right, we're going to throw Pikachu into the battle because Pikachu's awesome. And Brandon throws in a grass-type Pokemon called Cherubi, and we lose the battle. And we noticed during the battle that like Pikachu wasn't doing so well against this Pokemon, and maybe we need to be more strategic about which Pokemon we use. And maybe there are things that are missing from our class definitions that can help us win more Pokemon battles. So let's look at the two Pokemon that we're doing battle today. We have Pikachu, and wow, surprise, our Pokedex has new information. Now we know that Pikachu has the strength against a water type and a weakness against a grass type. And we know that Cherubi, the Pokemon that we were fighting, has a strength against a water type and a weakness against a fire type. So it's possible that because Pikachu's weakness was a grass type, we didn't do so well in this battle. Maybe we should have picked a different Pokemon. But how can we implement these strengths and weaknesses in our Pokemon class? And we can potentially add them to the constructor when we create each Pokemon, but that might be a lot of work when we have more than 2 types. Once you start getting water Pokemon, psychic Pokemon, ghost Pokemon, and that could get kind of crazy. We could also get the strength and weakness from our specific classes, like electric Pokemon or from Pikachu. In order to do that, we need some special functions to get the properties from our class, because those properties are protected. I couldn't think of a better title for this slide, but we sort of call them getter functions. So this is a concept in OOP that we call encapsulation, which is a fancy way of saying that when there are variables inside a class, the class is responsible for those variables or functions and kind of is a container around that functionality. And in order to pull functionality from that class, we have to use these getters to get that data. Getters don't really need to know where the data comes from. They really just need to know that the data is in the format that they expect. Let's look at some getter methods for our Pokemon class. So the first one we have is the get weakness, and this basically will just return the weakness property for that Pokemon. The other one that we have is the get strength function, and that'll return the strength. And what's missing here is obviously you would have to define those in the class as properties. And this is within the base class Pokemon. But if we go back to inheriting, we'll go back to our electric Pokemon class. And in this one, we'll actually show what the weakness and strengths of that class are. So this way we don't have to define them in the constructor, and we're still using our inherited classes. This brings us to a somewhat weird issue, and that's because I want to address the fact that we can still make a very generic Pokemon without the abilities of our extended classes, and maybe that's not very correct. So I'll show you what I mean. You can still make a Pokemon with the base class Pokemon, even though we now have a Pikachu class, and you can still get strength from the Pokemon base class, but that'll just return just a strength variable. And you can still attack with the Pokemon class, and you'll still get that attack class. But if you have a Pikachu, you don't really want that generic awesome attack. You want Pikachu's specific Thunderbolt attack. So having that base class Pokemon isn't really working for us anymore. And in order to give ourselves somehow to do away with this base class and only use the inherited classes, we're going to convert this base class into another OOP concept that we call an interface. And an interface is a way of sharing a base functionality without actually being able to create that functionality. So we won't be able to just create a Pokemon object, but we will be able to create a Pikachu or an electric Pokemon object. So if we talk about interfaces, they're kind of like contracts. They have code within them that has to be implemented by whoever makes a contract with them. So all methods are public, and the classes that implement this interface have to fill out the body information. So you can't create a Pokemon, but an electric Pokemon can create an attack function and have a specific attack. So I think it'll make more sense if we look at an example. This is our Pokemon interface. It uses the interface keyword, which tells you that it's an interface. And so far we have 2 functions in there that are setters, just some helper functions. We have our get strength and get weakness functions, and we have the attack function that we've seen a couple of times. If you'll notice here that there are no curly brackets, there's no body for these methods because this is an interface. You only have the declarations. The interface does not actually do any functionality. It just tells you, here are the things that you need to implement in your child class. Now that we have this interface, let's use it. In order to use an interface, you use the implements keyword. So here we have our class electric Pokemon, and it's implementing the Pokemon interface. And you can also do class Pikachu extends electric Pokemon. The reason we do this, and when we do this, basically Pikachu extends electric Pokemon, which implements Pokemon interface, so Pikachu has to implement the interface methods. And the reason we do this is because PHP is single inheritance, so you can only extend from one class at a time. So you can't really do electric Pokemon, Pikachu extends electric Pokemon if you had, and then extends Pokemon, so you kind of have to do this in a hierarchy. And if we want to go a little bit deeper into how electric Pokemon implements interface, let's look a little closer at that. And here's to get our methods from our interface, and you'll notice here we actually have bodies in the functions. It looks really similar to what we had before, but in this case, instead of coming from a base class, we're getting these functionality from the interface. And here again, we're returning water as the strength and grass as the weakness. I think I got that mixed up. Yeah, I think that's mixed up. But you know what? Don't judge me on my Pokemon knowledge. So if interfaces make sense, we'll go back on our journey. And on our journey, we've made some friends, and one of our friends actually gave us a gift. And it's a Firestone. And this evolutionary Firestone allows us to evolve our Eevee. So our Eevee's evolving. Wow, that's blurry. It was actually a gift. So you can use this stone to evolve your Eevee into a Flareon. But that creates a lot of new functionality that we haven't accounted for in our classes. So now some of our Pokemon can evolve. But evolution has very specific requirements. Some Pokemon need some stats, some Pokemon need some stones, some Pokemon need affection to evolve. So how can we add this to our interface? Can we add this to our interface? And the question is, if not all Pokemon can evolve, should we put this in our interface or not? Because if it's in our interface as a method, we have to implement it. There's another functionality that PHP gives us in OP that gives us more flexibility over the things that we want to implement, and we call this traits. And traits are basically snippets of code that you can reuse without having to extend from them, and without having to, without having to extend from them, and without having to create a trait. You basically have a snippet of code that you can use. In our case, because not all Pokemon evolve, we can have an evolution trait and only use it in the base Pokemon child classes that we need it in. So if we look at the Pokemon evolution trait, which is also just a bunch of code, we have like a function that says it evolves to, so we can give that whatever Pokemon is next in the evolution sequence. And then we have the actual functionality to evolve. That's a typo. Whoops. And so by using this trait, we can give specific child classes the ability to evolve without putting it in our interface, where then all Pokemon would have to be able to evolve. And then let's look at the syntax for how to use a trait. Basically, I did not update this slide. Poliwhirl is a water Pokemon, and it extends the water Pokemon class, and it uses the Pokemon evolution trait. So you have to use the use keyword and the name of the trait, and you're basically borrowing that snippet of code that we saw in the actual trait. Cool. That's all I have for today. I actually made double time, which is cool. We've covered a couple of OOP concepts, and I know that I went a little bit fast, but the idea was that you can kind of remember these analogies to help you when you're working with Drupal 8. I personally think that a really good example in core for looking at interfaces or inheritance is the block PHP, like the block plugin module, because it has a block interface, it has a block plugin, it extends from it, it implements things. So if you're looking to actually dig into the actual Drupal core, I would go to block and look for these examples, and maybe these analogies will help you better understand how things are connected. And congratulations, you have achieved the OOP badge, and you're on your way on the Drupal Pokemon journey. And that leaves us for questions. Yes?
Yeah, actually, I saw a little bit of OOP with Java, and I had learned to use private instead of protected, but I don't know exactly what is the norm with PHP, so protected, is it more used in private, or?
So the reason why I put protected there is because I saw it in core, so I assume that people would be more comfortable when they look at core, they'll see protected. Personally, I'm not sure what the exact distinction is, so I can't give you an exact answer, but I know that that's the convention with Drupal.
Okay.
I think in C++, private is you can only access when the class, within the class was protected, the subclasses can access that.
That might be it. Yeah.
So I think that's the distinction. I don't know if it's the same in PHP though.
I'm not sure. Is
I
it?
imagine it would be because you're using the same names. Right?
But basically PHP is written in C, so that will make sense.
That would make sense.
Well, no, because the language can be written in anything, right? You've got rules for languages, no matter what it's written in. So, but you're using the same terminology, so hopefully it's the same.
I can check on that and tweet at the Drupal Montreal hashtag. So I'll get back to you. Thank you.
And traits, is that sort of kind of like multiple inheritance? It's a way to cheat?
It's a way to cheat inheritance because sometimes you don't want things in your inheritance.
Yeah, no,
It's not used a lot in core yet, I think, but there is a string translation trait if you're interested to look into that. It's got very little in it and it's used in a lot of places. Cool. That it's definitely a way to cheat inheritance. Maybe that should be the traits are a way to cheat inheritance. Thank you. Any other questions? Oh, okay. Well, thank you. This is my Twitter handle if you want to keep in touch. And this is a Google form feedback, but you can also tweet at me, DM me, or come up to me during the camp. All feedback is really appreciated. This is the third time I'm presenting this, and I redid the slides, so I would really love to hear what it was like, if it was too fast, if I made mistakes or didn't cover enough information. So thank you very much for coming. And you've got time for lunch.